All right, so we're going to talk about data hunter-gatherers today, who they are. Are you and I data hunter-gatherers? Is it a good thing? And if not, what can we do about it? We're also going to discuss or introduce this concept of local data-oriented architecture today. But before we get into all this, I have this fundamental question. Do you remember, do you remember this? Any chance? This checkbook, it's been 6 years since I used one. But let me just ask this hypothetical question of what if you are forced by a bank to use this to make a transaction? Would you proceed transacting with the bank? Yes, anyone? Like, I wouldn't, because we are so used to the digital experience that we see today, and it is in fact easier to switch bank accounts and to start an account online than to write a checkbook and go all the way to the bank. So it is customer experience that is driving a business's revenue today. And we all know that customer experience is not just about providing a fancy app or anything. It's more about how to make a customer's life easy. And that's how these digital services become part and parcel of our life. And even when we know that digital experience is what is driving a business's revenue, why are some businesses struggling to provide that unmatched experience to customers? I think it's fundamentally because customer expectation is a moving target. We know that our expectations have taken a great turn in the last few years, and it has changed incredibly. But that's not the end of the story. It is still changing, and changing at a very rapid pace. Or in other words, it's a moving target. Let me explain this with an example. Let's say I have Alexa, and today I realize that my Alexa can pay my power bill. I didn't know that it was capable of doing that before. But the moment I realize that, my mind races. I immediately expect Alexa to pay my grocery bill, to transfer money to kids, to pay the mortgage, swimming class, and book a salon appointment, and so on. So as you see, as a customer, I don't even realize that I'm expecting something from different businesses that are supposed to be doing different things. So when it comes to digital experience, anybody in this world has the ability to move the target that other businesses are working towards. So when it comes to digital experience, you're no longer competing with the businesses just within your industry. You're competing with every single business that are providing a digital experience all around the world. So who is resetting this target? Who is the one that's disrupting the market most of the times? With customer expectations rocketing sky high, it is usually startups that try and exceed customer expectations and keep resetting targets for other businesses. This is what happens most of the times. Like, we have so many examples, like how Uber disrupted the taxi industry, Airbnb, and so on. On the contrary, large enterprises struggle to even keep up with these moving expectations. How many taxi industries have lost their business after the advent of Uber? Why can't they, come up with Uber-like experience quickly? It's basically because there is a fundamental difference between startups and incumbents. Startups are born digital, right? They're born in the world where digital experience is prevalent. So customers are front of mind for these guys right from the beginning. Whereas for incumbents, they still deal with a lot of legacy systems, processes, and business model, because these systems were built at a time where digital experience or even internet was non-existent. So how does it feel like to live in this world and deal with legacy systems? For those of you that have not worked on legacy systems before, I'm talking about systems like mainframes, JD Edwards, SAP, and so on, which are like big ERPs that were built a few decades back and that were meant to be doing end-to-end processing within a business, right from front end to back end to middleware and so on. They work very well even today, but just that they do not fit to today's digital needs. It's basically because they have two fundamental problems. One is lack of data insights. If we take an example of an airline industry or a travel agent industry, and if you go to their legacy system and look at a booking data, flight booking data of a customer, this is how it looks like. It's just an example, but you and I can't understand what it means. Like, we can take a guess, of course, but we need to involve a legacy systems expert to translate this data for us. Imagine putting this in front of customers, even in a translated format. Do you think this is good enough to attract a customer, to exceed their expectation? Maybe not. So this is one of the main, reasons, one of the main drawbacks. And the next one is lack of data access. In most organizations, even today, real-time data is only present in legacy systems. There are systems like, data warehouses and so on, but they only store historical data. So if I need to get hold of a transaction that happened a few minutes back, I would have to go all the way to legacy systems. And the problem is, they are usually covered with an application layer or a service layer, which means you can't just go to these systems and say, hey, show me all your data, let me choose what I need. It can't simply answer such questions. You would have to go to it with specific requests like, give me the booking data for this customer from this period to this period. Oh yes, then it can answer. So if you're living in this world, I'm sorry to say, you're living in the world of data, hunter-gatherers. You know how hunter-gatherers have to go all the way to forests to hunt for food, just like how you go all the way to your legacy systems to capture data. And after they hunt the meat, they realize that the meat is not readily consumable. They'll have to clean it, cook it, and then only eat. Just like how you would have to translate the data every single time you get it out of your legacy application. During those days, it was okay for them to spend one whole day to prepare a single meal. And next time they are hungry, they would have to start the process all over again, because there was no concept of stocking food. That was fine those days, but what world are we in today? Today, cooking is just a part of my day-to-day activity. I would want to spend my time more productively and creatively. Similarly, your technology team would want to spend a lot of time focusing on customer experience and innovation, because that is driving a business's revenue, and not necessarily on moving data across your organization, translating it, and so on. On the contrary, when you look at the startups, they live in the world of supermarkets, local supermarkets. They don't have to go all the way to forest or or farm to hunt for food. It's all available locally. So the data is available in one place, and most importantly, they are readily consumable. You go to a supermarket, buy bread and cheese, and you can make a meal quickly. This is mostly because their data is available on cloud, so access need not be an issue. But most importantly, as they store data, they also try and derive insights in real time. For example, when a customer makes a flight booking, you start deriving insights like, what is the average cost, money they spend on a similar flight, and how much have they saved or exceeded their expenses today, and so on. Now imagine putting this data in front of your customer in real time. As soon as they make a booking, you tell them, congratulations, you've saved $30 on your flight this time. That has the element of surprise that will attract the customers. And this is how you exceed their expectation and reset the target for other businesses. How do they do that? They either run, machine learning models on and understand your historical usage patterns, maybe not just for that one customer, but also by understanding the patterns from other customers that are similar to this customer, and so on. When you have the wealth of data, you can do wonders, and we all know that today. But imagine doing that directly inside your legacy systems. It can be very painful. So when you're living in this world of startups, and a business comes to you saying, we need to increase the bookings for the next financial quarter, and so just come up with a personalized discount offer to customers. And how do you do that? How do you understand what is a customer's favorite destination? This is where experimentation comes into picture. You come up with a basic idea saying the most frequently traveled destination is the favorite destination. It could be a totally dumb idea or a great idea. You wouldn't know until you put it out to customers. And this is why agility is quite important. So in this world, if a business is coming to you with such a feature request, it's a piece of cake because you have access to that data. And all you have to do is write the correct query and put it out to customers. And the whole process is going to take a few days. And of course, you may not nail it correct. You could get a customer feedback saying, this is winter and school holidays time. I'd rather get a discount for a holiday than for an official trip. And then you realize you need to add a few more factors like the time of the year. And you may have to go back 4 years down the historical data and not just 1 year to improve the accuracy of your algorithm. And that is a change. But the good thing is that is a change to just one place or to that one query of your algorithm. Or you could use machine learning, which means it could do it automatically and so on. But when we look at the same concept in a legacy enterprise world, when business comes to you with the same request, the developer, because he or she does not have any access to data, all that she has access to is an API catalog, you know. So she goes for in search for a booking API to get the historical booking data. And she realizes that this API only has upcoming booking details, not historical booking details. So she involves an integration team to help her update this API to include historical bookings. Now, integration team realizes that they do not get that data today from backend legacy systems. So they involve the backend team, help them translate the legacy data into JSON format. And then this integration team, they try to update the API, only to realize that this API is actually being used by the front-end mobile app, it's being used by B2B partners, it's being used by some internal teams, and it's too risky to update it in the given time. So they intentionally create a new API just to show historical bookings of customers. That's fine. At least this developer now has access to some data. But mind you, this data is not as wealthy as the data that the startup team had. However, this is some small snapshot of the same data, and you can develop the code by aggregating the JSON message, finding the most frequently traveled destination, put it out to customers, and this has taken a few weeks. It's because it involved multiple teams and multiple technology sets. And if they get the same feedback from customers, where they have to include a few more factors and go down, 4 years down the line to get the historical data, they can't do that in just one place. They would have to follow most of the process all over again. And when you compare both the scenarios, these incumbents, they've made 2 attempts and it's already a month because they have taken so long to get there. They've still not nailed the algorithm. Whereas the startups, they have made several attempts in 1 month and they've started seeing the spikes in bookings because they knew where customers are going to go. They were able to predict it more accurately. And so their bookings have increased for the next financial quarters. They even started getting new customers from these incumbents. Whereas when you see these incumbents as a business, they have not only invested a lot because they had to invest across different teams and different technologies, but they've also lost some customers in the end. This is how, in reality, startups are disrupting large enterprises today. And if you look at the difference, it's mainly because these startups, they had that direct access to data. Data was within their reach. But for these guys, they had to go through a lot of processes and obstacles to get that data. We keep telling that data is the new oil and that is the asset. Then what's the use in keeping that data just within your legacy systems, covered with layers of APIs and services? It is time to liberate the data. Gone are the days where business and IT were seen as two separate entities, and IT applications, IT people, and data were all, shared as a centralized entity. We started distributing applications, SaaS applications, and so on. We started distributing people in the name of product teams and agile practices. But data is still largely centralized in many organizations. With this setup, all we have achieved is distribution, but not decentralization. Decentralization is the key ingredient for agility. How do we achieve decentralization? It is time to start distributing data across these business domains. How can we do that? How can we reliably distribute data? Well, there are many ways to do that. One of the ways is to introduce a streaming platform like Kafka and start capturing changes from your legacy apps in real time through change data captures. By doing this, you're setting up a supply chain capability within your organization where this capability is getting the raw data from your ERPs and it is, populating your local data stores by processing the data into a consumable format. We call these local data stores not just because their access is local to that particular business domain, but also because the data takes different meaning in different business domain, depending on the context that they are in. To give you an example, let's say I have a booking data in my legacy system where that booking talks about my trip to Wellington and my return for 5 days. When I take that data and when I populate it in the local data store, I don't have to store that as one booking, but I could store it as two different bookings because if that business domain is a flight management business domain, for example, uh, this single booking involves two different flights that could have two different seats and two different schedules. So within flight management, if I have to notify a customer about a flight delay, it makes sense to keep them as two separate flights and not to notify them, for both the flights when there is a delay in just one flight. Similarly, in the hotel management business, I could store this as one booking if it involves one hotel, or I could store this as two bookings if it involves two hotels, and so on. So as you see, it is that one booking data which is replicated between different business domains. And these business domains are now no longer bound to follow the schema that was defined in some legacy systems several years ago. They have the liberty to store and define the schema in the way they want. And this gives them that autonomy. And when you give this wealth of data to the actual business domain teams, then they can start delivering at the speed of startups. This is one of the ways to do that. Traditionally, we would just create one booking API across all business domains. And because that booking is seen by different businesses as different things, that is why that API was struggling to, cater for all different needs. But this, allows us to get over that problem. And another advantage of this is this local data orientated architecture allows you to go towards event driven architecture. So when you start capturing changes from your legacy apps and start publishing events like the flight delayed event, any business domain can come and subscribe to that event. So when a flight management domain subscribes to that event, they can start notifying customers. But when a hotel management domain subscribes to that event, they can start notifying their hotel staff to be ready at a different time depending on the delayed flight. And when there is a new partnership, let's say with a car rental company, and when they come into the picture, they can start subscribing to this event and they can have their own processes on top of that, like reschedule a rental car and so on. So the beauty of this is this allows us to create a proper ecosystem-like environment where different species can come into existence or become extinct without impacting the rest of the species. So this is kind of what we're trying to achieve with this architecture. So to summarize the benefits of this architecture, it allows for a truly decentralized enterprise. When you rip a part of the enterprise and when it dies, the rest of the enterprise can still function. And that is the greatest advantage of this. And the second one is it allows you to have multiple innovation streams within your organization. Given you are a large organization and you have a wealth of data, if you can run multiple innovation streams, it gives you a competitive advantage to even go beyond startups and start, leading, taking charge. And the most important advantage is that you can start decoupling legacy systems because when you introduce a data layer in between the legacy systems and other rest of the enterprise, then that is true decoupling. But if you have synchronous APIs between your legacy apps and other applications, then that's not real decoupling because there is still some tight coupling between the systems. Yeah, so this is in summary what the concept about this architecture is, but I've had a few frequently asked questions which I thought I would cover in the next few minutes. One is how to distribute data. How many data replicas should we create? Will we end up creating hundreds or thousands of the same booking data or customer data replications? Well, this is where orientating these replications around business domains is going to be helpful. And this is where domain-driven design and identifying the bounded context will be helpful. The next one is what are the things that you need to consider? Obviously, because we are starting to replicate data, we need to make sure that the data reconciles in real time. And this introduces cost and complexity because we are having multiple data stores within the organization. There is a need to consider operating model as well because we are talking about domain teams, which means the team structures could change. And observability is very important. What if the data doesn't get populated in the local data store? How do you send alerts in real time? How do you make sure it is fixed before customers can see it? Security, the data is going to be accessed by many more people than when it was just within the ERP. So how do you make sure that the data is not misused by your technical team and so on? Just a last few things to note before I conclude. This, as I said, this architecture is very useful if the business is quite ambitious, if they want to innovate, if they want to lead and go beyond startups. But if all they want to do is just digital adoption, just create a front end layer for their business and stop there, then maybe you don't have to go through this route. And keep this as a last resort because we are doing this to increase your enterprise's agility. But agility is a relative concept. You do not know how fast or how quick you want to deliver things until you start trying it out. So you could start with other things like DevOps, automation, agile methodology, and so on. And if you still think you have not achieved the agility, then you could consider this architecture. And as always, start small. We talk about domain teams and so on, but most of the time, most of the organizations here are still reliant on heavily shared services teams. So it is a nightmare to just break an organization into domains teams overnight. So just start small and start with a single domain, test and give them the local access to local data, see if it works, and if it does, then expand it across your organization. So yes, data hunter-gatherers is not necessarily a good thing if you're looking at digital transformation and business innovation, but there are ways to come out of it. And local data-oriented architecture is just one of the ways. Thanks for listening, and I'm happy to take questions. Thanks, Alina, for your feedback. I'm just looking. Yeah, all right. I do not see any other questions as well on the Google Doc. I'll probably give it a couple of minutes. Otherwise, we can start with the next session.
Got a question. Siva, there's a question from George. How
Yeah.
could you use a new approach with business domain data?
Oh, okay. Sorry, I thought that was just a comment. So interesting how you could
Yep, yep.
use.
Cool. If no one else has any questions, we can take it over to Stephen with the next.
Hi there. Can you all hear me okay?
Yep.
Perfect. Let me I'll just shout if this doesn't come up. How's that looking? Can you see my screen okay?
Yep.
Perfect. Well, thank you, and thanks to our previous speaker. I just wrote a note there, but just it resonates really well how much of a distinct advantage startups have when it comes to this lack of legacy systems. But I think it was so nice and clear how the opportunity for legacy enterprises to transform themselves to move ahead on this is really on point. And hopefully I'll do some justice around this talk, which is on event sourcing, to maybe go and lift the lid a bit onto a particular approach around distributing your data. So with that, I'm here to talk to you on event sourcing from Wall Street to Main Street. June 24th, 2016. Pound US dollar at 149.20, 1.47, 146, 144.50, 133.10. Offered at a 140 handle, 139, 137, 135.20, 132.36. The British pound hit a 30-year low. People are shouting from the trading floor, we need answers now, what the hell happened? So you see, no one knew exactly what or if precisely when the world markets in foreign exchange would accept that the UK was going to remove itself from the European Union. But it turned out that a small city in a place in the north of England called Sunderland declared its voting results, and that's what made all the difference. So just to back up for a second, my name's Stephen Dewar. I was previously the global head of Morgan Stanley's foreign exchange core technology. And I spent almost 2 years working on high-frequency electronic trading platforms. Starting out in London, I spent time in New York, back to London, spent time in Hong Kong, to Shanghai, and back to Hong Kong again. Along the way, I married a Kiwi and eventually packed it all in, and we moved here to New Zealand in Auckland with our 3 kids. And so now I'm in a completely different world, working as an engineering manager here at Xero, and I head up their small businesses department down in Parnell in Auckland. So this evening, as it may have transpired, is that I'm going to introduce the concept of event sourcing and share with you how we used it on Wall Street for this particular Brexit event. And then I'll delve a bit deeper into some of the key principles as to why we'd recommend considering moving on to such an architecture but also the challenges this approach may bring. So first up, and whilst I'd love you to all be in the room with me, I'd like to get a sense of how many of you do relate to event sourcing, and maybe I'll get a virtual acknowledgement as we go through the chat. But without going into the basics, I will assume that event sourcing is where you capture all changes to an application state as a sequence of events. So let's sort of think about that for a second. A sequence of events. Everything that causes a change to your application and its application state must be captured in a sequence of events. So what I'm going to do is I'm going to unpack this with you, but the way I'm going to do this, I'm going to take you on a journey way back to a time back in 1976. And I won't share my age, so but let's just say that some of you will probably not be familiar with this. But this, in 1976, was at the time quite a famous game. There weren't that many games around, and it was known as the Colossal Caves Adventure. And I'm going to run you through an example, and you just have to bear with me on how this relates back to event sourcing. So the game involves textual navigation around a virtual world. You're standing at the small end of a small road before a small brick building. Around you is a forest. A small stream flows out of the building and down a gully. You get the option to choose a direction, so you choose to turn south. You're in a valley in the forest beside a stream tumbling in a rocky bed. You choose to turn west. This is how the game goes. In the game, the player controls the character through some simple based commands, and they can explore a cave that's rumored to be filled with wealth. The players earn points for acquiring treasure, and the objective of the game is to escape the cave with the maximum amount of points. Along the way, you can pick up keys, drop keys, use potions. There's a whole range of different things. But even with some clever shortcuts in the game, it still requires at least 215 moves in the fastest sequence to actually complete the game. So it was incredibly painful for people to discover all of the moves and paths so that they could identify and get out of the cave. Now, even back then, when the internet wasn't really formed, there was a legacy form of instant messaging platform known as RPC channels. And it became very common for the very small community who played this game to share their path and their command list of where they had tried out and the parts they had explored. Because there wasn't really much leniency in the game. Once you died, you essentially fell into a pit and broke every bone in your body, and you had to restart the game from scratch. So you can imagine if you're playing this game hours on end, you might start to write down this sequence of commands. To the naked eye, probably not that meaningful, but for players of the game, this was immensely powerful. And once you start sharing this with your friends and they start exploring different paths and different opportunities, slowly but surely, the full jigsaw starts to emerge, and you essentially get a very old school style crowdsourcing. Now, a couple of people took this one step further. These people are by the name Ralph Witt and David Platt, who actually used this command sequence along to project a full-blown visual map of the cave, just using the commands as an input. You see, the commands simply retained the intent of the original user. And it's this alone that allowed somebody to imagine a map with no other information. So what's the point? The point here is that the audit logs, the command sequence, are not only useful, but it's actually all that you need to have a truly deterministic system to allow you to map and explain your journey. They can be the only thing you need in order to figure out where you are at any point in the game. Just replaying the entire history will tell you exactly where you are. You don't need to store or remember where you are. You don't need to remember your current state. You just need to retain what I'd consider to be a provable audit log of your journey. So moving away from the colossal cave, where in industry will you see examples of people projecting current state just by retaining an audit log of how you got there? Well, two ones that may not obviously spring to mind, but are examples of this. First up, relational databases. Hopefully everybody can relate to on this webinar. Underpinning a relational database is nothing more than a transaction log. Going right the way back to its first entry of create database, there is then just a series of commands: create table, add column, insert row, create an index. And if you replay that transaction log in its order, you will construct exactly the current state of the database. So we've been here before. Something a bit closer to home at zero is accounting. So double entry bookkeeping. Double entry bookkeeping, nobody remembers the current balance. Why not? Because the moment you remember your current balance and don't remember how you got there, you create an invariant. You create an ability for there to be an inconsistency in your current state versus a provable way of how you got there. So instead, what people have in accountancy is just credits and debits. And if you want to figure out what your current balance is at any point in time, you just add them all up. So let's go back to the Colossal Cave Adventure and just review that traditional architecture. So a very defendable and appropriate way of building such a game would be a traditional CRUD-based architecture. Nothing wrong. The name doesn't sound glamorous, but there's nothing wrong. Create, read, update, delete architecture or approach. So as you're playing the game, as depicted here in this cube, every time you're navigating your way through the maze, you could imagine that based on your location, where you are in this maze, you remember the player, and with the player, you remember their current location. And every time they move north, south, east, or west, or pick up items, you just adjust their current state. Set state, update state. You can imagine the commands that were depicted. Absolutely fine. If we were to try and introduce this as an event-sourced approach and really embracing the notion of a command log, going back to those principles about transaction logs and with accountancy, what you instead want to be able to do is identify your current state through a calculation. So instead, what you would do is your game server will do nothing more than allow you to validate your command entries, go north, go south, go east, go west, and just store that information. And only upon being asked, where am I? What am I carrying? What have I put down? Will it process all the data in the event log and calculate the current state? If you change your event store and you calculate again, your state will change. But the state, when you turn the power off, is not resident or in memory. Now I'm just going to go back to the example that I described earlier on the 24th of June, 2016, and tell you a bit more about what happened here. It was approximately 11:23 a.m. in Hong Kong, which is where I was currently living. And it was convenient because it was a pleasant time in the morning, and most elections in Europe take place in the middle of the night. And I was sitting next to the head of our electronic trading desk as the British pound took the major slide. You see, no one knew that it would occur. But because we had an event source design, every single event, every market data tick, every trade, every movement in referential data was recorded in a log. And because that log wasn't just a log that you would use just for a human to read through, it was actually the database. When we wanted to reconstruct after the event exactly what happened, we were able to find a particular point in time, the exact minute of the day, of the hour, inflate an entire production environment, the back end, the front ends, all the presentation tiers, hydrate it with the event log. And then within hours of one of the biggest moves in modern day foreign exchange trading, we were able to record a video over the entire trading experience, for which we previously didn't know when would happen, edit, narrate, and fully visualize every single millisecond that happened and analyze to the nth degree opportunities for future consideration. We took the video, we did post-edit production, and we made it available to the rest of our trading desk. You see, the real key here is that where you have impressed upon yourself the value in being able to retain data to the high fidelity and being able to create customer value from replay is a distinct advantage of such an event-sourced architecture. But this is not cheap. And so what I'm just going to talk to you about in the next short while is some considerations. Because some of you who are familiar with event sourcing, or may have even heard of an adapted design pattern called CQRS, Command Query Responsibility Segregation, that's been both popularized by Martin Fowler and Greg Young, that ever since 2014, there's been a real danger that event sourcing would be applied primarily because it was fashionable. So whilst I believe this approach can produce incredible results, as I've just described, there are some really critical considerations that need to be made up front. And before I go into these 5 considerations, one that's somewhat implicit but is worth calling out is that you need to ensure that the product problem space that you're working on demands the benefits that event sourcing can bring, ensuring that these benefits are real and it's going to be a distinct competitive advantage, and that it's not an academic project for your technology team. So with that, I'm going to talk about the very first point, and that is people. Your people are first. The training required to be ready to handle event sourcing is non-trivial. First of all, you need to have an embedded domain expertise. If you're going to have a competitive advantage in the space, you need someone or a team of people who are going to be the voice of your domain language. As we just heard in the previous presentation, it's so important that you understand and can model your domain. But that doesn't come for free, that comes with experience. You need somebody who can help to teach, document the taxonomy so that everyone can participate a single ubiquitous language. And with ubiquitous language, the second key foundational part here is having domain-driven design training. Event-sourced architectures are built upon the foundations that Eric Evans has discussed around domain-driven design. And it's for that that event sourcing constructs are built upon. So you're likely going to have your wallet open, or at least have some very good access to good training so that you can sit and bring either seeding your team with a domain-driven expert who can train internally, or you have ability and are comfortable with sharing that knowledge and getting everybody up to speed. Not just your new starters, but every new starter that continues to join that team through the life of the product. And then finally, only once you've managed to go through those pieces, then can you go on to the next stage, which is event sourcing itself. You now understand, or you have an ability to access the domain. You have a way to think about domains that doesn't compromise the quality. And you can now start sharing domains and understanding bounded contexts, commands, events, understanding what are checkpoints, what are projections. All of this subtle thing, everybody needs to understand that who's going to be writing and building and architecting the platform. Second, the environment. Depending on how big you are or whichever company you're working in, it's almost assumed that the core domain that you're modeling is going to be a subset of the rest of your organization. In fact, to the earlier point, it's essential that you are breaking down your data into a core domain and that it's that you're focusing on, which means you're going to have to make some decisions. You're going to have to limit the scope of your domain. And this is very, very important. There's going to be stuff that's going to be considered core, and there's going to be stuff that's going to be non-core, and that's going to be on the outside. Something is going to have to translate those external events, external in the rest of your company or outside of your company, into your safe domain. This is what I would consider to be an anti-corruption layer. For every single component, we need to adapt that data into a way that you can prepare and protect. And that then allows everybody who's been trained up to that highly skilled core domain to be able to be natively event driven. Whether it's market data, trades, referential data, they can trust and just live in a very safe zone. This is really, really important. The third point is the architecture. It may sound crazy, but we didn't use a third-party platform for the event sourcing architecture. It was just a file. We just wrote a binary representation of data into a file on a disk. We held a time, an ID, and an event blob, and that was it. We had multiple representations of the file for resiliency, and we made it available across multiple regions. But to run a 24/7 global foreign exchange business, we had 6 nodes. That was it. It was incredibly fast, incredibly resilient, and had some conflict resolution, which was a hard part to make sure we didn't smash the network. But it was some pretty clever hashing algorithms, and that was it. It was simple. Keep it simple. If you want to be sure that you're understanding eventing well, you don't need to buy it off the shelf. The principles are quite simple, and as long as you have the experience at hand and the right training, you can do it. Fourth, data retention. And this point perhaps goes beyond this particular topic and gives a wider food for thought. But you don't need to retain everything forever. Yes, we have things like Amazon S3 and Glacier to store unbelievable quantities of data at almost no cost. No cost to them, and maybe not to you immediately, but sure, there's a cost of retaining data in terms of an ability to hydrate your systems. Event-sourced architectures have things called checkpoints, so you don't have to rebuild from from day 0. But it's important that in order for you to know that your event log is provable, just like a transaction log in a database, you can't just rely on some derived state. You need to regularly, whether it's daily or weekly, flex your ability to rebuild. You need to be able to regenerate the current state from the day 0 state. And with that becomes one of the most difficult decisions. And that is, do you ever delete data? Or maybe can you archive and retain the data? So our view, because we were generating so much data every second with every market day and tick and trade, was that there is a tipping point where the value of retaining data versus the cost of retaining it hits a tipping inflection point that it's no longer worth keeping in short-term memory or fast accessible memory. And we would maybe even put it into an archive for regulatory retaining or actually potentially delete it. And we deliberately built the pruning, which is what we called it, into the architecture so that as your platform becomes successful, you don't have a ticking time bomb around data volume. You've proactively been deliberate about how old and how young and how valuable your data is in your upfront design. And you can adapt. And the fifth thing, I'm sure we've all heard of speed of light, but we don't necessarily have to deal with it day to day. And it's probably one of the toughest of them all. And this comes along with some of the training. To accept that you cannot synchronize state transitions. and instead that you have to embrace the chaos that having even just a simple architecture of 6 nodes globally around the world means that you can't have consistency, and rather you can't control the sequencing of the events as they arrive. And in fact, you need to allow for them to have a consistently inconsistent state and embrace it is a really tough concern. We're used to having locks on tables and global mutexes and ways to synchronize. But if you want to truly embrace event sourcing, you need to allow for that eventual consistency. Identify conflicts and think about when there are conflicts, how you can auto-resolve them. This not only allows you to have simple bidirectional replication of data, but it also means that when you do have to recover from a failure of your system, that's just an everyday normal event in the office, because having one down and another person up and synchronizing between data sets that are out of sync is what you're doing every minute of the day anyway. You're always recovering from conflicts between your nodes. And this goes all the way to the user experience. Understanding if data isn't always guaranteed to be delivered in a synchronous form, how do you think about asynchronous design as a primary concern? It requires tight engagement with your design team. You have to reimagine the experience, but it's really fun. So what I would say is that if I can leave you with one thought, and that is that event sourcing is the kind of architecture that when it's fit for purpose, it can be truly indistinguishable from the joy that magic brings. But if applied to the wrong use case, you can trust me that the magic will be truly lost and you will be left in a pit of despair, just like in the Colossal Cave. And so with that, I'm willing to take any questions.
That was an awesome presentation. Thanks, Stephen. I love the fact that how you emphasized on domain-driven design at the beginning. That's something I've seen, yeah, in many places where that's not even considered until they realize that something is, missing. And also the fact that you could use files as event sources. I mean, for capturing, your logs is great. So that emphasizes on the fact that the architecture is more important and not necessarily the platform. Just because you have a fancy platform, you haven't achieved everything. You really need to get the architecture right. That's awesome.
Thank you. Thanks for your comments. I think one of the things is just to sort of, it reminds a particular point on there is that I think in the world that we live in and how easy it is to download a new library, connect to a new NPM package or a NuGet library, just because we're not writing the code doesn't mean we don't have a coupling. And I think that it's all too easy right now for people to accelerate themselves into using lots of decoration around their architecture before they've even started to solve the problem. And what we found though time and time again was keep it simple. Just keep it as simple as you possibly can. Resist the temptation to use third party. Resist the temptation to, even if it looks like it's free, the maintenance cost that will come with it, the upgrade path. It's not to say you don't use them, but just try and understand a little bit more than what you normally would, making sure before you flick on checkpoints from false to true, understand what checkpoint is. Do you really need it? When your checkpoints fail, do you know how to recover? These are things which, I've seen more people shoot themselves in the foot on event sourcing than benefit from it. And it really upsets me because it's not really because they weren't capable. It's just because they hadn't signed up to the sort of the manifesto up front with what was said on the tin. That's a really good point.
Yeah, and also I guess it's more of a mindset change for many organizations. So when we go to them and say that we can start using these logs as, a system of record, in real time, that is, they're like, because we are all used to that relational CRUD-based databases, it takes a while to understand that, we can retain our records in that fashion as well. So have you had any experience on that before, like convincing people around it, etc.? Sorry, you're on mute.
Sorry, can you just say that last part again? Sorry.
No, I mean, I just asked if you had any experience in convincing people around changing their mindset and moving from that relational database is like concept to moving towards event-driven design.
Yeah, I think, yeah, I'm definitely not against relational databases. They absolutely have a purpose. I think that if I consider the entire world of use cases, more often than not, people still default to relational or maybe a NoSQL alternative. So I think the amount of applicable cases is probably way greater than the cases that are actually modeled. But but what I see more often is people not being trained and not being fully prepared to the full cost of going onto an event-sourced architecture. And that's probably the more frustrating failing. The things about understanding the domain is probably something which is equally valid for relational data stores. Yep. But I think the problem with event sourcing is that there's a sort of a timelessness to the capturing of your events, in that you want to be able to reuse them for many years to come in their naked form. And so you want them to speak to the intent of the person. So if you don't capture that data in a way that speaks to the domain, it's very difficult for somebody to unpick it. A relational data store, by its very nature, usually stores the data, not in the way it was intended to be said by the user, but more in the way it was intended to be consumed by the data. It's more view-orientated rather than write-orientated. And so, to a certain degree, you've already lost with a relational data store because you've forgotten what was the original reason you stored the data. You just know why you're going to use it. And I find that you can potentially use a hybrid where you can potentially retain a log, not use it, but at least retain some insights so that when you come back to questioning how your relational data and why it was populated, you can kind of connect the two. That's probably an option I've seen. I see a question just came through from Elena and saying data retention cost is a good question. Even with personal photos, how many external drives should one have? Great question. And then another question there, just from George, when makes sense to implement of that architecture if you're going to have a high computational cost maintaining the event sourced architecture? I think where there is a high value applied to proving your current state is correct. If you think of it this way, if for legal reasons or regulatory reasons, or because it actually offers you a distinct competitive advantage over an alternative platform, if you can put high value and product and your strategy team really believe that there is a high value in proving that your data set is is correct, that's probably the key indicator for you. The accounting, if you get something wrong, it's just completely inexcusable for you to say the reason why the balance that you funded was incorrect is because we just had a bug in our adding in the synchronization between two data sets. It's much more defendable to say the debit was input incorrectly or the credit was input incorrectly, because it places the validation and places the problem back with the user's intent. But the moment you take somebody's data and you do something with it to store it in a state, you're taking ownership of the storage. And I think that that comes with a high cost, and the cost of that is a function of what are the consequences when it's wrong. So I would ask yourself that question: when it's wrong, how bad is it? Versus when it's right, how much are you willing to pay? And that's probably a good rule of thumb. And then, are you willing to pay to train the people continually as you lose people and you hire more people? Are you willing to get a domain expert in that's truly the best in the industry? If you can answer those two questions and you put the value, go for it. I think it's a brilliant solution.
Cool. Thank you, Stephen. And thank you, Siva, for the presentation. I'm just going to wrap it up and just want to say thank you to everyone who joined. Like I said before, we have the Google Doc. If you have any questions that we couldn't answer, or if you think of something after the presentation, please add them to the Google Doc and we'll try and get some answers for you. Thank you.